Welcome to the fourth installment of the summer assignment videos. In this video we're going to look at page 4 starting on number 25. And in number 25 we want to find asymptotes, just vertical and horizontal. Well, first off, vertical asymptotes are going to happen when the denominator of a rational function is equal to 0. And so in both of these, 25 and 26, we have rational functions, so we have to find when is the denominator equal to 0. So set those denominators equal to 0, solve for x. You'll find one of them in 25, but keep in mind, we've got a quadratic at number 26 in the denominator, so we will have two vertical asymptotes. Now for horizontal asymptotes, those are a little different. Those we need to look at the degree of the polynomial in the top and the degree of the polynomial in the bottom. So in number 25, when we look at the degrees, we have a linear in the top, which is a degree of 1, and a linear polynomial in the bottom, which is a degree of 1. So since the degrees are the same, we look at the ratio of the leading coefficients. And so that's 4 over 1, so y equals 4 is a horizontal asymptote. So our graph is going to approach the line y equals 4, but not actually touch it, not cross it. Okay? In number 26, our degrees are different. Our degree up top is a 0, and the degree in the bottom is 2. And so if the degree in the bottom is bigger than the degree in the top, then y equals 0 is a horizontal asymptote. So our graph is going to approach the x-axis, but not actually touch it in the end behavior. Now keep in mind, these are end behaviors, and especially when we get into the calculus course, we'll see some functions that actually cross asymptotes, but those are close to the origin, and we'll talk about that later. So y equals 0 is a horizontal asymptote. But what if we have a function, and we don't have one here as an example, but let's say we had a function that had the degree on the top that was bigger. So something like x cubed minus 4x over x plus 2. Well, the degree on the top is 3, it's a cubic, and the degree on the bottom is 1, a linear polynomial. And so since the degree on the top is bigger than the degree on the bottom, there are no horizontal asymptotes. However, there are something called oblique asymptotes. But we're not going to get into that here in this video. So just know that there is going to be an asymptote there. It's just not going to be horizontal, it's not going to be vertical, it's going to be oblique. Okay, so to find x and y intercepts, we have to think about, well, what's going on the x and y axis. So if we look at an xy plane, when we cross the x-axis somewhere, well, our y value is equal to 0. If we cross the y-axis somewhere, our x value is equal to 0. So to find y-intercepts, put in 0 for x and solve. And to find x-intercepts, put a 0 in for y, or put a 0 in for our f of x piece here. And then finally, you need to sketch a graph. So give the best sketch using your x and y intercepts and your asymptotes, and maybe even plug in a few more points to see what you may get. You're also going to do the same thing for number 27, sketch a graph of that. But in 28 and 29, we're actually going to solve some equations here, and we're going to find the inverse of this equation. We're going to do that by solving the equation analytically. So if we have a function, say like in number 29, that is y equals log base 5 of the quantity x plus 1, well, to find the inverse, we need to switch the x and y, put an x over here, and put a y over here, and then solve for y. So to get y by itself, we have to undo what is being done and work outside in. Well, to undo the log base 5, we use 5 as a base. So we raise 5 to the x is equal to y plus 1, subtract the 1. So we get our inverse of 5 to the x minus 1. Now, how can we test that? Well, we can test that by plugging this function back into the original function and see, do we get a value of x? If so, they are inverses of each other. For numbers 30 to 34, you're going to do the same process. You're going to use logarithms to take care of exponents, use exponents or exponentials to take care of logarithms. And so in number 30, you have a base of 4, a base of 2. So take a log base 2 of both sides, and then you'll get your x's down in the normal plane field. Number 31, take a log base 5, and 32, take a natural log, and 33, since we have the log base 3 of two quantities, those two quantities have to be equal to each other. And number 34, you want to use your log rules. Remember, with your log rules, when you add outside of logs, that counts as multiplication inside the log, and when you subtract outside of the logs, that translates into division inside. So log base whatever it may be, so log base b of a minus log base b of c is the same thing as log base b of a divided by c. Okay, so that's a rule that you're going to need to use there and then simplify from there.